Hi, hello, welcome back to another function. This is Krish Bavana. If you're for the first time, I'm a computer science student at University of Illinois at Chicago and I'm minoring in entrepreneurship. Firstly, welcome back to my channel. I'm really happy to see you all here today. Today we'll be talking about the stack in the assembly language. Firstly, there are three rules before watching the video. Rule number one, even I'm a beginner in this concept in the assembly language. I'm learning this in the class and I'm making these videos as a micro project for my class. So if there are any mistakes, please do comment down below. I will learn. I've done my 100% research, yet if there's any single mistake which I'm missing, please tell me so that I can correct it and others can get information too. Rule number two, it's more like an information. This is taught from the perspective of 0x 8664 language, and mostly all the problems that I show are from the C language. Then rule number three, please do watch the previous videos in the assembly language series if you have no experience about the assembly language. If you do have experience in the assembly language, continue forward, you should be able to understand it. So now let's actually get started with the stack in the assembly language. Stack. We all use stack in our programming language journeys for data structures, either for writing a simple program. Depending on whatever we have done, we all touched stack in our life. Stack follows the structure of last in, first out. For example, imagine a stack, and for example, say that we are pushing in numbers, maybe like 1, 2, 3, 4, 5. So let's say we are pushing in 1 first. So 1 goes in, then 2 goes in, then 3 goes in, then 4 goes in, then 5 goes in. For example, if you want to pop it off now, you'll be popping off with 5, 4, 3, 2, 1. This follows the structure of last in, first out. Whatever went at the last will be coming out first. It's the stack data structure that it follows. So stack, under the hood, it has linked list and a lot of fun stuff. But let's not go into that side of the stack. Let's stick on to the stack, which we'll be talking about in the assembly language perspective. So have you ever heard the word malloc? Memory allocation. So memory allocation is when you create memory on the heap. So when you create memory on the heap, you ask the memory to OS. So you ask the memory like so and so this much of space, and then you get that memory from the operating system, which is the heap memory. Have you ever wondered what happens if you don't get that memory from the heap memory? That memory will be stored on the stack. So stack is more like that immediate memory that you can register. For example, let's say you have some 4 or 5 functions that you want to call. Each one calls the other one. Let's say you have main, and then you have, let's say you have foo1, foo2, foo3 and foo4. For example, let's say main calls the foo and foo calls the foo1, foo1 calls the foo2. So it's kind of like a circle. And now once everything is done, stack starts popping off things. Stack removes it. Once you're done with it, stack doesn't want that function anymore. So it kind of dies. But heap, we ourselves have to go there and we have to clean whatever memory that we have requested from the operating system side. So here, today we'll be talking about this stack, the memory that we will be creating on the stack while writing a program. So I'm really excited. So now let's look at the example of how this stack looks. Firstly, let's look at this program. In this program, we have 3 functions. The first one is main, and then foo, and then bar. Each of them are interlinked. We're calling the other one from each one. So firstly, we start with main, as you all know, and then int I is equals to foo, which means whatever is being written from the foo will be stored in I, and then print I is we're printing whatever we got from the foo, and then we return 0. So now let's look at the processor stack. So now if you look at the processor stack, firstly we are pushing in RBP register. So when we are pushing in RBP register, it automatically creates another frame on the stack that we have right now. So firstly, what we had was we just had RSP, and now we are adding RBP frame, and then we are moving RSP and RBP. That means we are telling RBP is equals to RSP. So now both of them are pointing at the same thing. And then in the next statement, we are telling RSP is equals to RSP minus 16. So why are we using 16? So 16 means each frame is going to be 8 bytes. When we are saying 16, that means we are creating 2 extra bytes. And now in the next one, we are telling EAX is equals to, basically we're moving 0 into EAX. So let's say EAX is equals to 0, and then in the next statement we are having call foo. That means we will be calling in the function foo, and then we are telling move L EAX -4 RBP. So whatever is in -4 RBP. So RBP is the lowest one, and now we will be moving in the EAX value under the RBP. So that's how the processor stack works. And now in the next part, we're telling EAX. So basically EAX EDI move L. EDI is equals to EAX, and then we are telling EAX is going to be 0, and then we're calling the function print, and we're moving back 0 into EAX, and we're leaving and we're returning. So this is the basic main stack. So now let's look at the process stack for a recursive function, so that we can understand how the how recursive function kind of works with having the stack. So firstly, let's say this is the program that we have right now, and the program is, we have main, and then we have declared long x, and then we are saying x is equals to fact 5, and then we are printing whatever is being written from there at the end. And for the fact function, it's a written type of long, and then we're taking in a long n, and then we are saying if long n is less than or equal to 0, we're returning 1, or else we'll be returning in n times fact minus n minus 1. So you kind of see it's a recursive pattern function. Here is the assembly program. So here we have push q RBP, move q, and then basically everything that we've talked before. So now let's actually go into the program, and then let's see how each layer is being created. So firstly, let's say this long x fact 5. Here if you observe something, we are just pushing in the long, and then we'll be creating in a few new frames so that we have the space to push in whatever we want to. And then the next part is going to be coming to the fact function. In the fact function, we are checking if n is equals to less than or equal to 1, and it is not, because it is 5 technically the first time we pass in, so that we say RDI is equals to 5. And then the next part that we're going to do is we're going to call this recursive thing again with fact 5, and then after that in the fact 5 we are basically changing it to -1. Now it's going to be 4, and then the next part is going to be calling it again with fact 4. This time it's going to be 3, and then calling it with fact 3. This time it's going to be 2, and then calling it with the fact 2. This time it's going to be 1, and now finally when we call it for one last time with fact 1, this time it's going to be 0. If you observe something, even though everything is being called into the same exact function for multiple times, it is still creating its space on the stack. This kind of helps us give how memory is being traced, how we add different frames onto the single stack, because every time we call it, the memory is being proceeded, the memory is being created. There's no way that we can just say these are the frames that I will give and create in here. Every time we call it, we're creating new space. And also remember this, once we are done with it, we pop stuff, the stack is going to become empty as soon as we are done with the program. So this is a very powerful tool and a medium, so try understanding it. And finally, if you have any questions about the stack, or how function calls work, or how the procedure work, please do comment down below. I'll for sure reply. And if there's any comments or concerns from your side, also please do reply down below. And that's the video for today. Thank you so much for watching. I'll see you all very soon.